Aromatic amines, method of preparation and reactions of aromatic amines. Aromatic amines are organic compounds which contain, they are often actually based on one or more atom of nitrogen. Amines resemble ammonia in that the nitrogen can bound up to 3 hydrogens, but amines also have additional properties which is based on their carbon connectivity. This is classification of amines. Amines broadly categorized into three categories: primary amine, secondary amine, and tertiary amine. Primary amine contain one alkyl or aryl group which is attached to nitrogen atom. Secondary amines in which two alkyl or aryl group attached to the same nitrogen atom, and the tertiary amines in which three alkyl or aryl group attached to the nitrogen atom, and quaternary amines in which an ion in which nitrogen is bounded to four alkyl or aryl group and which bears a positive charge. Amines are further divided into aliphatic, aromatic, and heterocyclic amines. Aliphatic amines is an amine in which nitrogen is bonded only to alkyl group. Aromatic amines in which nitrogen is bonded to one or more alkyl group. There are some structures for primary, secondary, and tertiary amine. Aniline is an example of primary aromatic amine, and methyl aniline is an example of secondary aromatic amine, and benzyl dimethyl amine is a tertiary aliphatic amine. Next, heterocyclic amines. These amine heterocyclic amine in which nitrogen is one of the atom of a ring. Pyrrolidine and piperidine, these are the examples of heterocyclic aliphatic amines. Pyrrole and pyridine, these are the examples of heterocyclic aromatic amines. Next, aromatic amines. Aromatic amine is an organic compound consisting of an aromatic ring which is attached to an amine group. It is a broad class of compound that encompasses aniline but also many more complex aromatic rings and many amine substituents beyond NH2. Such compounds occur widely respectively. Aromatic amines. Aromatic amine is an organic compound which consists of an aromatic ring which is attached to an amino group. There are some examples of aromatic amines like aniline, sulfonic acid, 4-aminobenzoic acid, 2,4-dimethyl aniline, 1-amino anthraquinone, 9-amino phenanthrene, and 1-amino 9-fluorine or 3-amino 9-ethyl carbazole. Method of preparation of monoamines. First, reduction of nitro compounds. Monoamines are nearly always prepared by the reduction of the corresponding nitro compound. It is performed in the presence of metal and minerals, example tin, zinc, or iron, and HCl or H2SO4. Nitrobenzene is a monoamine that reduced in the presence of zinc or HCl or tan or HCl in acidic condition to give aniline. Next, ammonia lysis of aryl halide. Aryl halides like chlorobenzene react with ammonia in the presence of a catalyst like copper salt at high temperature 473 Kelvin and under high pressure to form the corresponding amino compound like aniline. Next, ammonia lysis of phenol. Phenol reacts with ammonia in the presence of zinc chloride at high pressure to form the aniline. Degradation of amine. This reaction is also known as Hoffman rearrangement. In this reaction, primary aromatic amines like aniline can be obtained by degradation of aryl amine like benzamide with bromine or chlorine in alkaline solution. Next, action of hydroxyl amine and hydrocarbons. Aromatic hydrocarbons like benzene react directly with hydroxyl amine in the presence of catalyst FeCl3 and AlCl3, which is also known as Lewis acid catalyst to give monomers like aniline. Let's method of preparation for secondary, especially for secondary and tertiary aromatic amines. First, alkylation of primary and secondary aromatic amines. Primary and secondary aromatic amines on reaction with same alkyl halide like ethyl bromide in the presence of sodium hydroxide to give secondary and tertiary aromatic amines like N-ethyl aniline and N-diethyl aniline. Next, reduction of amylides. Amylides like acetanilide, are reduced with lithium aluminium hydride in the presence of ether to give secondary and tertiary aromatic amines like N-ethyl-aniline and N-ethyl-N-methyl-aniline, which is a tertiary amine. Reductive amination. Aldehyde and ketones react with primary and secondary aromatic amines in the presence of a reducing agent like nickel to form the secondary and tertiary aromatic amines. Like aniline reacts with ethyl-methyl ketones in the presence of Raney nickel to form secondary amine, and formaldehyde reacts with N-propyl aniline in the presence of zinc or HCl to form tertiary amines.